Hello everyone, starts the Apollo 8 RTCC Real-Time Computer Complex tutorials. It's been a long time coming. Uh, so to fly RTCC, you're going to need a few things. Firstly, for landmark information, it's really nice to have a calculator on hand so you can do some quick maths. Reason being, longitude over 2 for the computer. RTCC is a standard longitude. So if you don't want to do all that multiplication in your head, calculator is great. The second thing, you'll need the flight plan for that mission. You'll need some kind of transcript, preferably from the flight journal. The journal has everything cleaned up, making everything look really nice compared to the raw transcript. And then the third thing is, if you can find it, some ground rules to follow, some ground-based mission rules. And yeah, I typically refer to them less in Apollo 11, which we'll be getting to when I clean up my notes on that some more. But with Apollo 8, the ground rules are so critical to this mission, and we'll see why later. And those are usually the things that that I will fly with. So this video will demonstrate what you need to do before a launch. Well, you don't really need to do it before the launch, but I always do in case you want to check out the the ascent trajectory monitors and stuff. And then I'll go through a brief walkthrough on everything that there is to do in RTCC. So, to demonstrate the RTCC, instead of switching, views a lot, I figured it would be just better if I had this pulled up, the MFD here. So we can go into our RTCC MFD, and it's recommended you have, 2 or 3 windows out. But we can go through and talk about everything. So the first thing, we'll go into configuration. And here we could see some different things. We are not flying with a LEM, so this option here, stage, doesn't matter. We've got, RTCC files. We're in Apollo 8, so don't touch any of these, but here you're able to load in, an SFP file, an initialization file, your TLI profile, and your constants in there. So if you're making like a custom mission, great place. We have the date of the launch, the liftoff time, and we've got the ability to update the liftoff time, and we've got the epoch, the AGC epoch. I don't remember exactly what this is for. It's not a setting you can change, so it is just there. And then we've got a selection for our CSM and our LEM, and then if we're docked or undocked, and our thrust and CG tables. Again, great for some, different things. We could set thrust on the SPS and whatnot for the purposes of calculation. So if you're making like if you're doing what Max is doing and you're making a custom engine, you can put in thrust profiles here. So super powerful tools offered to you, but the only thing you want to do before launch is just set your CSM for Apollo 8. This is Apollo Spacecraft 503, AS-503. Most of our things are going to be done with the mission planning table. A lot of people find it harder to do it this way. I personally find it easier, but that may be just because it's how I learned first back then when other people were learning. The mission planning table wasn't a thing, so I personally find it a little bit easier to manage. There's a whole ton of options here. We'll talk about them later, but a general gist overview is the mission planning table allows you to have a view of your planned burns. So, for example, if you're going to burn TLI, you would see the information here, and you can use that to generate a pad. But it also affords you to be able to pick spots in between maneuvers and calculate trajectories on maneuvers that haven't been done yet, but will be done. So you can plot multiple maneuvers. For example, you could say, you know, here's TLI, and then we can plot, like, here's undocking, like, an hour later, and then here's mid-course correction a little bit later, and we could do all of those calculations based on just some preliminary pre-burn assumptions. And it's not like something we'll heavily be getting into in Apollo 8 because it's just us. But we will get into that a lot in the LEM. We'll see quite a bit of it here close to LOI when we're getting those abort pads, and we need to have certain things on the table, assuming certain burns and not assuming certain burns. So it'll be fun. And quite frankly, that's why I think the mission planning table is more intuitive, because it offers that view. Without it, it's kind of hard to keep track of what's going on, in my opinion. Your MPT initialization. This is where you initialize your vectors for everything. We'll talk about this later, but basically this is what the system is looking at to get your trajectory information to make some of those assumptions and those calculations. So this is like the pre-configuration before you activate your mission planning table. Utility, there's a lot of stuff in here. Landing site information, which is pre-plugged in since we're flying Apollo 8 and not a custom mission. We've got RefSmat stuff, nodal target conversion, IMU parking, angles, descent orbit, or abort. Most of this stuff we're not going to be touching, just pretty much the RefSmat. But we can also do like lunar impact targeting if we're flying a mission which doesn't preload a S4B like pre-programmed trajectories. I forgot exactly what that's called. We were just talking about it yesterday, actually, and I just completely forgot. But also, if you're doing like custom missions, you can, you know, input your own like terrain modeling here. So yeah, ton of cool stuff. We're not gonna touch a lot of it. I don't even know how to use most of the stuff on this window. So I've never flown a custom mission, so that's a story for another day. But preliminary advisory data, here we can get all of our pads, our nav check, map, landmark tracking, our entry pads, you know, whatever we need here to generate for maneuver pads and whatnot. It is all in this window. And then we have the maneuver targeting. Here we can do things like rendezvous. If we're doing like just like an inclination change or a plane change, we do like general purpose maneuver inputs here. Translunar is where we're going to be looking at our mid-course correction processing. Since we're flying a pre-configured mission like Apollo 8, we will not need to touch the TLI processor. So if you're flying a custom mission, a TLI processor is going to be your best friend. But it is all pre-programmed into the S4B ahead of time in Apollo 8, so we don't need to touch that. We got our lunar orbit insertion computation systems, you know, return to Earth for calculating aborts and TEI. Deorbit, this is for like Apollo 7 and 9. Lunar descent planning allows us to plan out different phase changes, descent orbit insertions, whatever. Lunar liftoff planning window, that's for LEM stuff. Lunar launch targeting table. I don't really touch this, but it's like helps you target the lunar launch. It's like the lunar liftoff planning window, but just different. I've never used it, so. And then we can perigee adjustment. So it's general overview. This is where all of our calculations of our burns are going to be. Uplinks here. We get, you know, all of our uplinks that we would get in an MCC controlled mission. Our navigation update, landing site vectors, external delta V from burns, refs mats, entry updates, erasable memory updates, you know, anything we want here, it is here for both the CMC and the LGC. And then the last sort of window here is the MCC displays. This allows us to pull up, you know, some whatever information we would like. For example, the launch analogs, when we're in liftoff, we could take a look at this. We could see the chart moving, just a cool thing to look at. And then, you know, mission planning. We've got the Fido orbit digitals. We'll be using the skeleton flight plan, which we can actually access a different way through that sort of route. But we'll be using, a lot of times we'll be using the, where is it? Space digitals on 82. And here we can see just our vector information for general, like HAHP, our velocity. We can see our lunar information, basically, so our height at Paris, or our height at closest approach, our latitude and our longitude, our apsidal crossing. We can also see the entry information, so separated into 3 nice and neat columns here. So just a couple things we'll be touching. And then the last one that's worth mentioning is the 1629 display. If you're making any inputs here and you know, things aren't calculating or you're getting errors, this is a great place to check, as you'll see the error codes, and you'll either get okay as things are done, or you'll get like an error code, and you can use that to troubleshoot. But this is sort of like how they interfaced here. You can make certain inputs, like most teletype-ish kind of display here is pretty cool. Ground tracking stations. We can, you know, ground tracking, actually it's not that one. It's here, expected site acquisition. We of course aren't lifted off yet, so we're not going to calculate anything, but we could see, you know, whatever station, acquisition time, the range, the altitude, and the time of cutoff. Yeah, so really cool stuff. So just a general overview. Again, maneuver calculations, preliminary advisory data, most notably the refs mat here, setup for mission planning table. This views the mission planning table, and then the config. There's a couple things we need to do pre and post launch. Just make sure you've got your CSM set up as AS503. How you'll be uplinking to the computer, and a couple fun displays you can toy around with. Most importantly, being space digitals and online monitor for planning purposes and for troubleshooting purposes. So it's just a general overview of the systems, and I'll catch you after launch in the next one. So thank you.